accomplish. We have a carbonyl that we're going to convert to an alcohol. Have we ever seen that transformation? Looks like a reduction, right? We need to reduce the carbonyl at some point as part of our transformation. And we also have this carbon as a bromine, and now it has a carbon change, so that's a new carbon-carbon bond that we also need to accomplish as part of our synthesis. So we need to do two things. We need to reduce the carbonyl and form a new carbon-carbon bond, and we can do either one first. Doesn't really matter. So let's say we wanted to do this disconnection. Okay, if we want to do this disconnection first, we look at these two carbons and we say we want to make this, one of these has to be a nucleophile, one of them has to be an electrophile. So because this is the carbon with that now has an OH, what does that look like? I think this was my electrophile as a carbonyl. And how about the other carbon? How do we make this a nucleophile? Remember, we have an alcohol product here. How do we make an alcohol? What two ingredients do we need? We want a ketone plus a Grignard. Ketone plus a Grignard gives an alcohol. So this is my carbonyl, and the other carbon we're going to make a Grignard. So if I had this Grignard and this ketone, well, it's not really a ketone, is it? It's two carbons, so it's just this aldehyde. So let's say it's a ketone in quotes, and in this case it's an aldehyde plus a Grignard. If I had this aldehyde and this Grignard, that can make my product. Okay, so that's a good plan. The problem is that this alcohol, that Grignard, is impossible to make. We have another example of incompatible groups. It is incompatible because this Grignard is a very strong base, extremely strong base, just like we use butyllithium as a strong base, a Grignard would be a really strong base, and of course an alcohol is an acid, is acidic. And so if you have a Grignard in the presence of an alcohol, it simply protonates the Grignard, you quench your Grignard, the reaction's over. There's no way you could use that. Okay, so what we can do is we can protect. We have to protect our alcohol in order to do this Grignard. Okay, so we kind of have a plan here. Let's think about getting to this alcohol first. Okay, how did we get this alcohol? How do we go from a ketone to an alcohol? Looks like we've lost a CO bond. It's a reduction reaction. What reducing agent would we use? Something like lithium aluminum hydride or sodium borohydride. We could do sodium borohydride and some kind of protic solvent like methanol or water, ethanol. We can do that reduction reaction, no problem. And then instead of making the Grignard, we have to first protect the alcohol, and the way that we protect the alcohol is we're going to protect it as a trimethyl ether, or any of the silyl ethers, but TMS is kind of our most simplest one we can use, most common. So we can make the TMS ether. How do you make the TMS ether? You use TMS chloride. You put a leaving group on that silicon, and that's what gets replaced by the oxygen. Again, some kind of base like pyridine. We can use here TMS chloride, pyridine would be a way of making the TMS ether. Okay, the reason I wanted to do that is because I wanted to make the Grignard here, and I couldn't make the Grignard in the presence of an alcohol. Now I no longer have an alcohol, it's protected, so now I can add in my magnesium, and that has no effect on the TMS ether. This is protected. It's not acidic, and so this is an okay Grignard. There's no problem. Those are now compatible functional groups. Okay, what did I want to do with that Grignard? I wanted to react with acetaldehyde. So I can bring in acetaldehyde. Step 1, step 2, H3O plus to work up my Grignard. Kind of running out of a little room here. and that forms the new carbon-carbon bond. So we've done the reduction, we've formed the new carbon-carbon bond, we're very close to our final target molecule. All we have to do is remove the protective group that we put on, so we're temporarily hiding a functional group while we'll do reaction somewhere else in the molecule, and then we want to be able to take that protective group back off. So how do we get rid of a TMS group? We use TBAF, tetrabutyl ammonium fluoride, to do TBAF. Okay, so this is one approach to the synthesis where we do our reduction first and then we do our Grignard. Let's see if we could do the other order and see what that synthesis might look like.